Hi, this is Steve Barton. In the last video, we showed some of the tools that we made, boring bars, some face cutters. Some of the viewers said that they'd like to see the build on some of these tools, so we thought that would be a good idea. We actually planned on using, in one of the future videos, using that boring bar fixture to show how to make boring bars, but we thought we'd start out with the simplest boring bar to make, which will be this style. If you have just a milling machine, you can make something like this quite easily. You don't even need a lathe, and we'll show you the build on this. Not only will we show you the build on this, we're going to show you some neat things that you can do with this as well. How you can set this up and actually cut some very accurate diameters by locating this tip off the center line of your tool. There's different ways of doing that, and we'll demonstrate some of that as we get further into the video. But what we wanted to do was show that over here you can see I have a lot of carbide, actually broke tools. I never throw away my carbide. A lot of times if it's high-speed steel, in mills, center drills, chamfering tools, whatever. If it's high-speed steel or if it's carbide, I hang on to that stuff because I will shape them into tools and tool bits that I can put inside this style boring bar. This one right here is just a broken center drill. It's a high-speed steel. I have numerous sizes, 1/8 inch, 3/16, 1/4 inch. I got them all the way up to probably about a 1/2 inch. But most of the stuff I use is a 1/4 inch or less for this style of a boring bar. And so what we're going to do, we're going to make one of these bars. I already cut me some stock. This is 01. I just happen to have that. I prefer A2, especially if you're going to heat treat it. If you use 01 for your tools a lot of times and it gets an oil quench, you have stress that's in that tool that will work its way out for years, even if you normalize it and everything. There's still a lot of stress. It's because you're taking a hot piece of steel, when you quench it and you bring the cooling down that rapidly, it's just going to put a lot of stress. One of the things that you'll find a lot of stress in, if you do your own heat treating by hand, and you'll see this, a lot of times people will heat treat something like this and dunk it and quench it and all this stuff. They'll put it in, they'll drop it in the oil like this. That is the worst way you can do that. What will happen is you're going to have rapid cooling down here. It's still going to be hot up here as it hits the oil. And what's going to happen as it cools here, the material is going to contract. And it's going to put a nice bend in your part because it's cooling fast down here as it's hitting oil and still hot up there. So if you're going to quench something like this, you always want to quench it where you're going down in your oil in this direction. By doing that, you're quenching and it's cooling off faster as it comes up. You don't have any distortion on your diameter. So if you do some heat treat, you want to be careful about that. But this stuff is a drill rod. You can buy it from any industrial supply house. This happens to be 3/4 inch drill rod. And a lot of times I'll buy the drill rod because of the fact you got the sizes. This is ground. It's probably within a 1/2 thousandth of a nominal size. And it works great when you want to make tools that you just want to throw in a collet, or those standard holders. Like with this boring head, you got a 3/4 inch diameter there. A lot of times that stuff will just fit in there just perfect. I buy it in 36 inch lengths. You can buy, again, the nominal diameters. Most supply houses that I've dealt with, they'll carry it in 01 and A2. This just happens to be 01. We're going to make a boring bar. I won't even heat treat this one. I'll just leave it soft. If I was going to heat treat it, I would prefer A2. But we make these boring bars. And when I make a boring bar like this, I have a 3/4 inch head so that I can fit this up into my boring head the boring head and use it in conjunction with that. I can also take it and just put it in a 3/4 inch collet in the mill and use it there. I already cut a chunk. It's a little bit smaller. We're going to make it a little bit smaller in length than this. And we'll make one of these tools. We'll move over to the milling machine right now. I got things kind of preset, and as I said, all you need is the milling machine. I'm going to be cutting this diameter down to about a 600 thousandths diameter from this 3/4. I'm going to use a nominal size. It's easier for setting your tool, and some of the methods I'll demonstrate later. If you have a milling machine and you get some carbide inserts or other cutting tools, we have a lathe, but it's not accurate enough for doing a lot of the stuff we do, and a lot of this simple stuff like this is so much faster to do in the mill. And we've showed this already where you can use your milling machine to do limited lathe work, and so we're going to start out today doing that. So we'll move over to the mill right now, and we'll start showing the techniques we use. When we come to the mill, I have a lathe tool using a 55-degree diamond carbide insert. What I'll do on our lathe tools, I'll measure these on the granite because I want to know the exact distance from the backside to the very tip of this carbide, and then I'll just take a pencil grinder and I'll scribe that dimension. Well, this is 748 thousandths from the back to the actual cutting tip. And what I've done is I've already set this tool in the vise. I got it at a slight angle to give me a little more cutting relief in that direction, so I can do good shoulder work. And what I'll do is I'll throw this in a collet. I just want to skim and face the bottom side off. I'll flip it around and get the length just where I want it. So I got to move this over. I got my zero is on the back of the tool. 748 is the exact center line. I'll line past it, bring my slot back this way. And I actually got to add 100 thousandths from my edge finder. I didn't do that, so I'm going to go 848. Actually, I want to stay about 1 thousandth under the center line, so we'll go 849. And then I'll lock the table down, so we're not going to move that direction. Already got the speed set, about 2,000 RPMs. Down a little bit. Just run a file to break that edge. So what I'm going to do now, I'm going to mark this off. I want about 1.5 inches that will be sticking up in the boring bar holder. It's going to leave me about 3 1/8 inch I want to make sure I got at least 3 inches sticking out. What I'm going to do now is just take a 3-inch gauge block, stick up in my quill, bring that down like so, lock it down, get the RPMs back up. 0. I can move my 3/8 gauge block out. Now I can cut it, or 3/8, I can cut a 3/8 step now. Now I got to establish where I'm at on the diameter. Or 743 on the diameter. I'm going to move over 371.5. Reset the digital to 0, and I know I'm cutting per side, but as I move in 1/1000ths, I'm cutting 1/1000th per side. I'm getting 2 out the diameter. I can change the digital to radius or diameter. I don't like to do that because if I forget to change it, I usually mess my next project up. So I'm going to leave it over here. What we got to do is I want a 600,000th diameter, and so that means I need to wind into 300. So I'm just going to go. Let's see if it'll handle a 25,000th cut. We got the automatic feed on at 3,000ths per rev. Turn that off real quick. Here we should be within about 20 thousandths of 600. 621. We'll take a couple light cuts to bring her in. Take the deflection out. .609, .608, and a half on the top. I'm going to cool this off a little bit. about 3/10 taper, which is really good for a mill. We're about 603. (602/10), 599/4, 601, or yeah, about 3/10 under. We got a little bit of taper in it, not much, but that'll be fine. So anyhow, we're real close to 600. I'm going to slow this down, and I'm just going to break the edge. One other thing I'm going to do is I'm going to actually come down and take a blank pass on her. It'll probably be a little bit under 600, but it'll take some of that taper out. And what I want to do is when I get to that shoulder, instead of winding back up, I want to wind the table this way so I can clean that shoulder up nice and smooth so there's no steps in it. We have about 7/10 taper in the part, so it's not too bad. I'm going to pull this out a little bit more because I've got a burr here. Okay, so we got that part done. So that's what we're ended up with right now. The next stage, let's see, gotta find the 45 template. Right in front of me here. That one's too thick, so we're going to do this one right here. take this smaller diameter now. We're going to pinch it in the vise at a 45-degree angle, and we're going to put us a hole in there now. And so I know my zero is zeroed on the back of the vise, so I'm going to wind this in now, because I know I'm at 600 thousandths diameter up here, and I want this to be right in the center. So right now I'm located halfway, and I'm going to eyeball just a little bit off the peak on this side. What I'm going to do is I'm just going to come down and just try to take the center drill real careful. Put a little spot on there. And the reason I'm doing that, digital there are good. And now I got to put an end mill in there. I wanted to cut some of that center out a little bit. What we're going to use is a center cutting 3/16 inch end mill, and we're just going to spot face that down. We're not going to cut all the way through. We're just going to spot face down in there so that we got a 3/16 clearance. As I drill and ream that hole, I'm not going to have any deflection. Okay, I'm going to take just a little bit of a break right now because I want Adam to take a camera and get a picture of the spot face, a close-up on that so you can see what I just done here. But the idea by putting the spot face is, so if I try to bring a drill, reamer, or other cutting tool down on this peak over here, it's going to deflect the tool. It's more likely going to break the tool, make a real ugly hole. By taking an end mill, a 3/16 diameter, which is going to be the diameter of our cutting tool that we're going to put in there, by going down in there and spot facing that, I can take the part that's protruding up on the angle, I can make it so it's already at a 3/16. Now when I take a smaller center drill and go through there and ream it, I won't have to worry about deflection on the tool. So Adam's we're gonna cut from this scene right now. Adam's gonna get a picture of that so you can see exactly what we've done.